to review limits and we're going to review continuity. It wouldn't be a bad idea to have your limits cheat sheet out. You need to know that thing back to front. Perfect. What's the first thing you try to do when you work limit problem? You plug it in. So on number 1, you plug it in. Cosine is 0 is 1. 0 minus 5 is negative 5. So negative 5 times 1 is negative 5. Okay? Easy peasy. Done. We hope they're all that way. Number 2, plug in B. You can't. You get 0 over 0. What's it mean when you get 0 over 0? More work to be done. This one you have 2 options. You could use L'Hopital's rule, or you could just factor. Factoring to me is easier on this one. But if you prefer L'Hopital's, B is a constant. So when you do L'Hopital's, it goes away. You would get 3x squared over 6x squared, and you can work from there. But I would prefer just to factor, because L'Hopital's you may have to do multiple applications of. This is a difference of perfect squares, right? Those cancel. 1 over x cubed plus b cubed. Now if I plug in b, I get b cubed plus b cubed, which is 2b cubed. Oh, wait, 1 over. Any questions about that one? That one was kind of a tougher limit problem. The next one's also a tougher limit problem. If you plug in 0, you get 0 over 0. What are my 2 options on the second one? For solving it. If I get 0 over 0. Good. I can either multiply by conjugates or I can do L'Hopital's. Neither one is particularly great. L'Hopital's does require a derivative of a square root, which involves a chain rule, so you've got some work there. Conjugates, you got to multiply the top and bottom by 2 plus the square root of x minus 4. Either way, it's okay, but probably neither way is your favorite limit problem. So number 3, if I do the derivative of the top, I get negative 1/2 4 minus x to the negative 1/2 times negative 1 on the top. On the bottom, I get 1. And then I would still do the limit as x approaches 0. Then I can plug in 0. I get 4 to the negative 1/2 power. You do have to know in this format what a negative 1/2 power does, which I hope you know.
Police Department eruption. I'm the chief of following students in the high school office. Chris Sunday, Madeline Rich, Natalie Burklow, Daniel Kirkendall, Joey Kelly, Aaron Draper, George Moran, Patrick Simpson, Bill Pulliam, Taylor Lee in the high school office. Thank you.
4 to the negative 1/2 power is the square root of 4, which is 2 on the bottom of 1/2. Now, that's L'Hopital's rule. I do want to show you conjugates. I almost think conjugates is easier on this one, less to get lost in. What was the original numerator? 2 minus 2x. So I multiply by 2 plus the square root of 4 minus x on top and bottom. And I get 4 minus x on top. On the bottom, I'm going to leave all of that just multiplied together. On the top, 4 minus 4 is 0. Negative x is a positive x. X's cancel. And I'm doing the limit as x approaches 0. So I get 1 over 2 plus the square root of 4, which is 2 plus 2, or 1 4. So that's conjugates and L'Hopital's, same problem. I do think the ones involving square roots are some of the more difficult. The only other ones that compare are probably the ones with fractions that you have to common denominator. So, any questions about that one? Okay, moving along. Number 4, the limit as x approaches infinity. What do we look at for as we're approaching infinity? The powers, right? This is a horizontal asymptote question. And so I get negative 3. The next one, same thing. I look at the highest powers. The higher power is on the bottom. approaching infinity or negative infinity, that's going to be 0. Higher power is on the top, which means I'm going to either approach positive or negative infinity. I just have to decide which one. And this one's a pretty easy decision to make. Everything's positive, and I'm approaching positive infinity, therefore, positive infinity. The next one's not quite as easy. The square roots, remember, always kind of threw us a little bit. I've got a square root squared. Now, what is the power of the denominator? 1. So these have the same power, right? So this should equal 3 at some level. I do have to decide whether it's positive or negative 3. If I were to plug in negative really big number, the top would be negative, but the bottom would be positive because the square and then square root. So a negative over a positive makes a negative, so that was a tough one. The limit as it approaches 1 of f of x on a piecewise function. I'm going to look at where I'm coming from the left. So coming from the left, I get e to the x. Coming from the right, I also get, e to the first. Coming from the left, I get e to the first, and coming from the right, I also get e to the first. So that limit is e. Do not confuse that with a continuity discussion. This is just a limit. We'll get to continuity momentarily. That's just a limit. Any questions about that one? Okay, the next one, which one grows faster, e to the x or x cubed? E to the x, so this is an infinity or a negative infinity. The numerator is bigger. I have to decide whether it's positive or negative infinity. If I plug in a really big number, a really big positive number, the top is positive, the bottom is negative, so therefore negative infinity. When we first learned this one was a really difficult problem. I get 0 over 0, and I had to try to figure out a way to use the special limits, sine of 3x over 3x, and 4x over sine of 4x, and how to break it up and do all that fun stuff. This one is a great candidate for L'Hopital's. What's the derivative of sine of 3x? Cosine 3x times, and what's the derivative of sine of 4x? And if you plug in 0 into sine or into cosine of 3x and cosine of 4x, you get 1 either way. Questions about that one? Last one. What is that? Derivative. This is the derivative of sine of pi over 2, right? Which is cosine of pi over 2, which is, recognize it, let's go fast. Questions about that? That is a crazy fast limit review. Was it good though? Okay. Next we have continuity. I feel like we reviewed this just a couple days ago when we all missed that open response question. Was that on this actual exam, or was it on a, was it on the actual exam this time? Okay. So this is kind of where that comes from. The formal definition of continuity, and anytime you are justifying or proving, you have to go back to formal definitions. A function is continuous at a point x equals a if and only if 1, the limit as x approaches a exists. So if you're proving or justifying that a function is continuous, 1, you have to go through a proof that the limit exists, which may involve showing that the limit from the right and the limit from the left are equal, and so therefore the limit exists. You have to show that the point exists. So at the point you're considering, you have to say f of 3 equals 5, so f of 3 exists. And then the final piece is you have to show that the limit and the function value are the same. That way not only are you coming in from both sides, but you're also hitting that point. You don't have a hole there. So all 3 of those things have to be met for a formal definition of continuity. This set of notes, and I am recording today, so I will post this online. But this set of notes is from September 3rd. Thank you, Tony. So you can look around September 3rd for limits and continuity. August will be where you find more of your limit videos, and September 3rd will be where you find, September 3rd and 4th will be where you find continuity. Any questions about that? So if you want to go watch full videos that aren't so fast, August, day 1 in this class through the end of August is where you'll find all of your limit videos where I fully explain all of them. And then September 3rd and 4th is where you'll find continuity. There are 4 kinds of discontinuities, and really, I'm going to 4 kinds of discontinuities. There are holes, vertical asymptotes, jumps, and oscillations. So those are the types of discontinuities. We looked at some AP questions. You know, when is it? If the limit is x approaches 3 of f of x equals 7, which must be true? None of those must be true because the limit's equal to 7. That doesn't mean f of 3 is 7. If f of 3 is not 7, then it wouldn't be continuous. I have no idea whether it's differentiable. So the limit just doesn't tell us that much. It just tells us, you know, remember the diner? It tells us we're going to the diner. It doesn't tell us if the diner's there. It might have burned down, remember? Any questions about that? These we kind of went through, determine if the following is continuous, and we kind of went through a definition, and then we would, on these we stopped if we ever got to a place where it wasn't continuous. So you see on the first one, we show that the limit from the left of f of x is 0, the limit from the right of f of x is 0 to 0, f of 0 equals 0. Therefore, we're continuous because all 3 of those things equal. Does that make sense? Now that's not a justify problem. That's just find it. So if we were justifying, we'd probably throw in a few more words. But other than that, any questions about this? The other type of problem that shows up on continuity is this type. If f of x equals this and it's continuous, what must a be? Well, if I plug in 3 into the top and I plug in 3 into the bottom, I better get the same thing, right? If it's continuous. So a times 3 minus 5 should equal 3 plus a. And you would solve that equation for a. Now, when we learned this, this was all we could do. AP will also occasionally make this a 3-part piecewise function and say it's continuous and differentiable. Find A and B. Well, then you do it very similar. You do something like this, but then you'd also take the derivative of each piece and set those equal to each other. So if it's differentiable, the derivatives would have to be equal at the breakpoints. So that's kind of how they could take that to a little bit another level. You've seen problems like that, but it's been a while. Feel good about our discussion of limits and continuity? Did I go too fast or good? Good pace? Okay. All right. I'm going to hand out a limit